Alright, now that we've explored a little bit of IK chains and extracting controls from our base skeleton, let's do a little bit more of a deep dive into kinematics solvers. There's two more that we can explore, well, kind of like one and a half, and we're going to explore them in the rig VOP. So we're starting to dive into a new VOP that was introduced with kineffects and a lot of new VOPs that are part of kineffects. We'll notice we have 4 inputs, and similar to an IK chains over here, we want to input our rest slash base skeleton that we want to affect into one of our inputs. Due to the nature of how VOPs work, it doesn't necessarily have to be the first input. I like to do it into the first input for organization, and any control geometry into second or ladder points. We dive into our VOP. We can see that we have an interactive viewport here, where when we hover over each of our joints, we can see several versions of our joint pops up. If we click on one of our joints, just clicking, we can toggle between the different points, and when we click and drag on one of the points into our VOP Vex Builder, we can see that we get a get point transform from our top one there, and if we use a bottom one, we get a get transform, and our very bottom one is a set point transform. So you can think of these 3 points as our output, input from one of our inputs, and input from our other input. We can see here that our get point transform is just grabbing a point by name from our second input. And same thing goes for our point 1, it's by name and just by our first input. So by the nature of how we organize things, we can tell that this is our rest skeleton joint, and this is our control skeleton joint. So that's how we can grab points from Vex. So you can either place down your nodes by typing them in, get point transform, and determining it by hand, or you can interactively grab them from your scene. If we wanted to set up a kinematic solver in here, we can search kinematics, IK solver, and we can see that we get an IK solver. Our IK solver looks kind of similar to our IK solver node on the SOP level. We can see that we have a root, a goal, and a twist, and we can see we have target points here. Our signature is basically how this information is presented to us. I'm just going to leave that as it is. So our target points are the points that we are affecting, and our control file points, as we can see, are being grabbed from the second input. Of course, if you've reorganized your inputs, you'll want to go in and change that. This is why I like to put the rest/affected skeleton into our first input and our control skeleton into our second input. So we can set up a kinematic solver in a very similar way here, and you can do it either by typing in your names, or your point numbers rather, or you can connect them with your get point transforms. So our root is going to be this point 0, and this is our root there, and we can see we can hook it up as such if desired. We can see over here that our colors and titles don't really match up with our set point transform, and this is because our IK solver is setting multiple points. So we want to get set point transforms with a plural S, and then we can plug in our X form and our points there, and we can see that that has already started to affect our joint chain. It's naturally grabbing 0, 1, and 2 as our root, goal, and twist, which if we dive back up to our outputs here and we turn on our numbers, 0, 1, and 2 are all that we have. So it's naturally grabbing the correct numbers, just in the wrong order. Our goal is actually number 2, and our twist is actually number 1. And there we go, it's actually more properly affecting how we'd want that IK to be solved. And we can see that it's doing something different than our IK solver up top. It's creating this sort of arch rather than a proper solve. And let's investigate that. Firstly, we need to determine our orientation of our joints properly. Unlike our IK change, which kind of helps us do that automatically, we need to do it by hand. If we want to see our orientation, we can right click in the viewport and we can display joint axes. So negative Y is currently being used, but positive Y is what our base chain here uses. So we'll want to switch that over to positive Y as our look at, and we can see we are already getting a better solve for this. And our up axis, as we can see if we dive into our base chain here, our Z axis is actually pointing towards our twist joint, which is in this case the up axis, so we want to switch that over to Z as well. And there we go, we can start to see that the deformation is no longer doing any weird things. Our bended curve here is matching much better with our base line, and we can start to affect the IK solver however we wish to, with some nice additions here that aren't present on our SOP level of things. We can see though that this version of our solver is not taking into account the straight lines of our joints, and the reason for that is that we're not blending our joints like we did with our SOP. We're interpreting them based on just those 3 points there, our triangular system, our control joints. So there's a main difference between the 2 different solvers that we have here. We can adjust some parameters in here, like keeping a root transform if we want that base to kind of stay positioned upward. And we can just generally play around with how this IK solver is different than our other IK solver on the SOP level. In a way, you can think of this IK solver in our attribute VOP, kind of similar to that of a spline solver for something in like Maya, where we have a curve and we're affecting the curve, and that is how we are changing the IK instead of having a simple 3-chain structure. We can get this IK solver to act like our simple IK solver up here. With this parameter right here, use simple solver for 2 or 3 joints. If we turn that on, we can see that something immediately breaks, and that's because our target points are taking all of our points, which is 8 points or 9 points, which is more than 2 or 3 joints. If we determine our joints either by bringing them in and combining them, or if we just know the numbers, which I will just go take a look at here, we need 0, 4, and 8. Then we can dive back in and put those in, 0, 4, and 8. There we go. So we get a very similar deformation to our IK chain SOP, but we get the benefit of our VOP node, a little bit extra attributes here, such as our stretch, which is really just a 0 or 1 kind of thing. It's either on or off, which if we turn it on and we hop back up to our rig pose and start to manipulate our IK here, and we push it beyond where our joint can normally solve for, we start to get that nice stretch in the mesh. And we can do the same for the squash if desired as well. Squash doesn't seem to have as major of an effect, but we get those two added benefits, and if we turn that off, we can see that if we were using it like that kind of spline solve, we can have a lot more fun and sort of play around with the unique aspects of using this as the IK solver instead of the basic SOP solver. So that's diving into a little bit of the VOPs part of KineFX. So we have this IK solver set up with our VOPs now, and we have this interesting sort of problem that we have where we can keep the root transform here, so we can keep the orientation of our input joint to keep that kind of flat. But what if we want to keep the orientation of our tip as well? Well, instead of just putting this directly into our deform chain, if we put into a skeleton blend, and we can see here the orientation we want that we are controlling with our control chain here, and we got that stretch going, but we want this orientation to be met with just the tip joint. We can kind of force it by using this skeleton blend. We can put in our control chain here and our new base chain here, and for this skeleton blend we just want to blend that tip, and we want it to blend towards our control joint in world space, since we have that difference in structure. And now when we plug that into our deformation and we check it out, we can see that that tip, especially if we just look at it in this orientation mode, is completely in line with how we had our control. Now, since we earlier were looking at the skin weights of the tip of this tube, it doesn't really affect much, but we can have that kind of control, which is useful later when we are setting something up like an arm, for instance, where we want to maintain that tip's orientation as well as the base orientation. Perfect. So we have explored the solve IK VOP, and there's one more IK solver that we can explore, which is the curve solver, which is very, very similar to a spline solve spline IK in my other DCCs, where we can take a number of target points and control points, which we're just going to continue using our IK controls and our regular chain, and we can instead plug these guys into our set point transforms, and we'll notice that we need to reorient our axes again to match our needs, so our Y up and Z positive. And we'll notice that our curve order currently is at 4, but our control points, we only have 3 of them. So there's a mismatch there, and if we just plop that down to 3, we can see that we build our Bezier curve, which we can change between polygon lines if we want, which gets kind of wonky for a curve solver. So Bezier curve or NURBS curve. I'm just going to leave it at Bezier curve, and we can come back up and see that deformation. how we want it. We'll notice that our z-axis got flipped a little bit here, so we're just going to go back to z negative, and then we're in line with our base joint chain. Which, if we ever want to stop seeing our input joint chain and our output joint chains, we can right click in our viewport and we can uncheck display inputs, and then we'll only see the output. But I kind of like seeing the inputs. We get to see our control points and our baseline. Here we could play around with squash and stretch just like our other IK solver, except for the squash and stretch on the curve solver, in my opinion, works a bit better. As we can see here, that squash really comes through and that stretch is very nice as well. Of course, since this is a curve solver, if our points kind of collide and do this weird thing, we're making a very sharp curve there that's just based off of our line. So our mesh starts to deform kind of oddly. So it can get strange, just like any kinematics can get strange when we get our points too close to one another. So explore that if you want, and it's a pretty cool solution. I think we'll be using it a few times for our character for specific use cases. So this was a brief introduction to the curve solver. Let's move on to constraints. We'll be exploring the curve solver more later in the course, where we have some good use cases for our character rigging and some solutions there.